All right, so this video is about reflecting on the coordinate plane. We talked about earlier that a reflection is a type of transformation, again called an isometry, where the figure will remain congruent after we have performed the transformation. So a reflection, another word for reflection is a flip, okay? And so what we're going to do here is we're going to take point A and we are going to reflect it over the x-axis, which is difficult to see here on the video, so I'm going to outline it. That is where the x-axis is. Okay, so we are simply going to reflect it. Now, when you think about a reflection, when you look into the mirror, first of all, your reflection is directly across from you. Okay, so that if I were to draw a line down the middle, that would be perpendicular. You would have 90 degrees formed, 90-degree angles formed. So when you go to reflect on the coordinate plane, you want to make sure that this A, that the reflection A prime, is going to be directly across from it. Not over here, not over here. It needs to be directly across. Second thing that you want to make sure is that it is the same distance away from the reflection line. So right now, A is 1, 2 above the reflection line, which makes sense because the y value of the coordinate point is 2. That means A prime needs to be 2 units away from the reflection line as well. It will just be on the other side. Again, think of looking in the mirror. Your reflection appears to be the same distance away from the mirror as you are on the other side. And the closer you move towards the mirror, it appears as if your reflection moves closer as well. If you step away from the mirror and get further away, so does your reflection. So that same rule holds true here. So if I want to reflect A over this line, again, I need to make sure to go straight across. A is 2 up, so A prime needs to go 2 below. So there is the reflection point, A prime. This is the coordinate point, 3, -2. Now, if I wanted to reflect A over the y-axis, and again, that's hard to see, so I'm going to trace it here. The same idea. I need to be straight across, and it needs to be the same distance. I'm going to do this one in a different color. So straight across would be over here. A is 1, 2, 3 to the right. So my A prime has to be 3 on the other side, to the left. 1, 2, 3. So there is my A prime for the reflection over the y-axis, and this is the coordinate point, -3, 2. Now if you look, you can see there's a bit of a pattern here, okay? When I reflected over the x-axis, my x value stayed the same, and my y value became the opposite. I went from a positive to a negative. And if I started down here and went the other way, I would have gone from a negative to a positive. When you look at the reflection over the y-axis, you can see that this time it is the y values that stay the same, and it is the x values that are the opposite. So in general, when reflecting on the coordinate plane, if you reflect over the x-axis, your coordinate point, xy, simply becomes whatever axis you're reflecting over, that's the point that will stay the same. So my x value will remain the same, and I will do the opposite of my y value. So if my y value was positive, it'll become negative, and vice versa. If it was negative, it will become positive. Now, if I am reflecting over the y-axis, similar rule, I take the coordinate point that I have, xy. This time, the y value will remain the same because I'm reflecting over the y-axis, and it is the x that will be the opposite. So if you follow this general rule in whatever reflection you do, you can always reflect correctly over the x and y axis on the coordinate plane. Now, if I need to reflect more than one point and reflect a triangle, for example, A, B, C, okay, you are simply going to do the same thing that we did. So I'm going to reflect this over the over the x-axis. So over the x, all right, and I'm going to do the same thing that I did when it was one point. See, a triangle or any other shape is just reflecting a point more than once. I'm just reflecting 3 points. So in this case, A is 1 above, so I need to go 1 below. C is 1 above, so I need to go 1 below. B is 1, 2, 3, 4, 5 above, 1, 2, 3, 4, 5 below. And again, I suggest labeling your points immediately, and you can see how that has flipped and how you can reflect a whole figure. Now, the other thing we need to talk about is something called reflection symmetry. Reflection symmetry is any object that has a line of symmetry. Most of you have heard of a line of symmetry. A line of symmetry is basically a line that can cut an object down the middle, either vertically, horizontally, both, diagonally, and what it does is it creates a mirror image so that both sides are exactly the same. Humans are said to have a line of symmetry. If you were to cut us vertically down, basically on both sides things are the same. Here, I have a rectangle, a blank piece of paper. Now, a blank rectangle has two lines of symmetry, one vertical down the middle and one horizontal down the middle. Now, some people think that it has a diagonal line of symmetry here because it would look congruent on both sides. However, the other way you can think of a good line of symmetry is not just that it cuts it in half so that both sides are the same, but you could fold it and everything would meet up. So if I fold this along the vertical line of symmetry, the rectangle meets up. If I fold it along the horizontal line of symmetry, same thing. It's a mirror image. Everything matches up. If I try to fold it diagonally, you can see that not everything matches up. I have extra paper here and extra paper here. So there is no line of symmetry diagonally on a rectangle. So a rectangle has the two lines of symmetry.